reciprocals that you had to do was your reciprocal of your cosine. So here's your cosine graph. Okay? And if you set it up like we did your other one, at your zeros is where your asymptotes are. So if you kind of look at your zeros for your cosine curve, do you see where your asymptotes go? They went to your pi over 2, your 3 pi over 2, 5 pi over 2, negative 1 pi over 2, negative 3 pi over 2. This is just like your tangent. So your domain is going to be real except, and I don't write my domain like that, real except when x is equal to n pi over 2, where n is an odd integer. You have to qualify this. Everybody see the odd? It's when you set up your function, whether it's cosine or sine, anything that crosses at the 0, when you take 0 over 1 and you take its reciprocal, 1 over 0, you can't divide by 0. So that's where your asymptotes come, at your zeros. You can almost kind of see your guideline, right? Once you draw the little bumps on it and you come off of those, you can almost kind of see that has to be your guideline. It's kind of what, it's obviously not in the middle here. It's right around in through here. This has got to be your guideline. And your range again is the opposite of your cosine. Your cosine goes negative 1 to 1. This doesn't use negative 1 to 1. It uses negative infinity to negative 1 and 1 to infinity. Okay with that? All right, make sure you write your domain like this, not like theirs. They just went in from 0 to 2 pi. That really doesn't tell us our domain. We know our domain is our real numbers for our cosine and our sine curves. Okay? And your cotangent works a little bit differently than your tangent. Now, here's your tangent lines. So again, the blue is your tangent. Nope, the red is your tangent. The red is your tangent. Here's your tangent line. So right here were your asymptotes for your tangent. Any of your zeros are going to become your asymptotes for your cotangent. So your zeros for your tangents, that's where your asymptotes are. And your cotangent just works the opposite way. It comes through the 0, comes through the 0 here, just goes the opposite way. And so now we're going to write our domain, real numbers, except when x is equal to 0 pi, 1 pi, 2 pi, negative 1 pi, negative 2 pi. So n pi, where n is any integer. So did you kind of see a little bit of similar things here? Your tangent and your secant were the same, and your cosecant and your cotangent were the same in terms of domains. Somebody's phone. Okay? And again, your range on this guy, all real numbers. Your asymptotes, remember to say x equals. Now, they only went from 0 to 2 pi. So ours is this, where n is any integer. Make sure you say any integer. It can't be any number. Yes. And we use n. Yeah. Not for everyone. The cotangent and your cosecant were the same. Your tangent and your secant happen to be the same. It's wherever your asymptotes go. Okay? Either they're going to fall at n pi over 2, or they're going to fall at n pi. The n pi's, say n is any integer. The n pi over 2, say odd integers. Okay. That is consistent, at least there. Okay, so we're okay on that one? All right, so let's see what happens now when we have a secant with a transformation in it. amplitude changed to 1/2. What does the 2 for frequency do?
It makes it small.
Okay, it shrinks it horizontally because now we need to complete 2 curves in 360. So how much for one curve? 180. So at the 180, we're going to complete one full cycle. And how many quadrants in one cycle? 4. So we're going to divide this into 4s. We're going to take a look at our halves, and we're going to set up our cosine curve. So we're going to go 1/2, 0, -1/2, 0, 1. And we're going to do it again. 1/2, 0, -1/2, 0, 1/2. Now, you can make it a dotted, you can make it a solid, whatever. I'll try a dotted here and see how I come out. I normally stink at making curves as well. Okay, so here's my cosine curve. Do I have 2? I have 1, 2. My amplitude is 1/2, right? Now, locate your zeros. Here's a 0. This is going to become an asymptote. Here's a 0, asymptote. Here's a 0, asymptote, asymptote. We're going to make your secant curve for this. So we work off your cosine curve. Now, at the tops and the bottoms of the little mountains here, we're going to make your reciprocal. Down here, up here, and this guy has a 1/2 of one here, and the other 1/2 goes into that side. There's your 1/2 secant to x. Just work off your basic curve first. It's much, much easier. Now we have to find this domain. We have 2 ways to do this. Okay? The first way is, we can certainly just look at this. What is this angle right here? That's 1/2 of 90. 45. So in terms of radians, pi over 4, right? This guy's pi over 4. Then this guy would be 2 pi over 4. This guy over here, 3 pi over 4. 4 pi, 5 pi over 4. Can you set this up as a domain for me? Reals except what? X is equal to what? N pi over 4, where n is what? Is an odd integer. Okay, that's one way. Just looking at our graph, we can look for the pattern. Now, the other way is this. Remember that sheet that I gave you that had all the reciprocals and all the domains? This is when that comes in handy. Look at the domain for your secant. What is the domain for your secant? That we did yesterday. Your domain says all real except n pi over 2, where n is an odd integer, right? Now, we're going to take this guy right here because that's equal to x. What do I have here now instead of x? 2x. So now I'm going to set x to 2x and take this and solve for x. See it? So I can divide this by 2. I can keep this, switch this to 1 over 2, and I get n pi over 4. Same as we got up here. Same as we got up here. And you keep the same thing when n is an odd integer. We have 2 ways to do this. You can do this by looking at your graph, looking for a pattern. We can do this by taking your secant, and instead of x now, we have 2x. Because you changed it. You have a horizontal shrink. So if you shrunk everything down, right, you had to also shrink where your domain was. Does that make sense?
Can you just go over how you
the exception up here,
And then
right? Anytime you take a 0, and this is like 0 over 1, when you take its reciprocal, it's 1 over 0, which we can't divide by 0. So this is the part that becomes undefined, where your zeros catch your original function. That kind of gives us our guidelines to graph our reciprocal inside of. This also tells us our exceptions to our domain.
so if it's like 0, it's an odd integer.
Well, if in this case, look for your pattern. This is at half of 90, which is 45. So that one was there. This one is, okay, so if I set these up by 45, this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi, 5 pi over 4, 6 pi over 4, 7 pi over 4. I noticed on all my odd ones, when this is odd, that I can't use that, right? So that's how I start. I say n pi over 4 when n is odd. That's all I have to say. Now, if we walk back and we figure out, oh, your secant said, your secant was, any secant function was x is equal to n pi over 2, where n is odd, right? An odd integer. Right now we use 2x instead of x. So we can come here algebraically and say, I now have 2x. Let me do this one differently. Let's cross multiply this. I have 4x equals n pi. Maybe this is easier to see, cross multiply. Divide by 4. There it is. N pi over 4, where n is odd. You can do it algebraically, or you can do it by looking at your graph.
But you don't substitute the n pi over 2 in for the x?
We set it equal to the, we start here, it was equal to your x, but now you no longer have x, you have 2x.
So if you have like 4x, would you...
4x equals n pi over 2.
Fx.
Yes. So if you did this, 4x, where n is odd, right? Then you would turn this into 8x equals n pi, divide by 8. Whatever it is, we're going to substitute that in. Most of the time, you should be able to look at it right from your diagram, because it does make sense. You're looking for patterns when you do this. You're finding a pattern. Which ones can I not use? Okay, well, we're going to do another one. We're going to do a couple. All right, this is one of your homework ones. Now, tangent. It's easier if you look at it and take the 1/2 out of this. So what are we exactly changing on this? What are we changing on your tangent if we do this? The frequency. So tangent normally has a period of pi. So we're cutting it in half. We're going to give it a period of pi over 2. So every 90 degrees, we want your tangent line to curve on us, okay? Now, your tangent normally goes like this. Here's your 90. It has an asymptote. This is your tangent curve, right? And again, asymptote. Now, what we want to do is cut this in half. And we also want to figure out where your asymptotes are. If you look at your domain for tangent, we said all real numbers except when x, this is for your tangent curve, is equal to n pi over 2, where n is an odd integer. Didn't we say at the pi over 2, at the 3 pi over 2, right? Those are the parts that we can't have a tangent because we can't divide by 0. I now want to take 1/2 of x. And I also want to keep, if it starts with n is odd, I got to keep n is odd. Okay? So far, so good? Okay, 1/2 of x. Is it alright if I put the x on top, or if I leave that? X over 2?
How do you know when the number has to be an odd integer?
Because when we looked at our tangent, we said this was pi over 4, 1. This was 3 pi over 4, 4. This is 2 pi over 4 in here. And 2 pi over 4. 1, 2. And that's the same as your pi over 2. Oops, hang on. Let me backtrack. This is, we didn't change it yet, sorry. This is your n pi over 2. This is 2 pi over 2, which is pi. This is 3 pi over 2, which is 270. These are the ones we can't use, right? So I look for a pattern. I say 1, 3, 5, 7, -1, -3, -5. So I know it has to be an odd integer. My even one is this. Pi is the same as, if I add 1 to this, 2 pi over 2. Isn't that pi? That's my even one. So my even ones are good for my tangents, but my odd ones are not good for my tangents. Now, I bring this, my original domain, and I set it equal to this guy, before we use 2x, right? Now we have x over 2, or 1/2 x, whichever one you want to use. Cross multiply this guy. And solve for x. So I divide by 2. So x is an n pi, where n is an odd integer. Okay? This one means, am I stretching or am I shrinking with a half? Stretching. So I'm spreading this out further, aren't I? So now instead of every 90 degrees, 2 would give me every 45, so the 1/2 is every 180 degrees. Doesn't that make sense to me? 180 degrees, I will put an asymptote here. And you got to kind of keep the same thing that you had before, where n is an odd integer. You're going to keep that one. And you're going to keep your same range. What is your range? All real numbers, so your range stays the same. Now the easiest way to graph this guy is like this. Start when n is an odd integer. So the first one I want is at pi. And then at 2 pi is okay, 3 pi is bad. So here's my asymptotes. And at -pi. So all you got to do now, because you're only sketching for me, is sketch a curve. Just bring it through here. Bring this through here. See it? If you set your asymptotes up, it's a little easier. The shrinks are a little easier to see than the stretches. Shelley?
So, wait, never mind.
You okay? The stretches are a little harder to see. The stretches say you want to expand. So instead of every, okay, think of it this way. Instead of every pi over 2, you're kind of doubling it to pi. Every pi is going to be your asymptote there. On your odds. Keep the same as your information from before. Sometimes it's easier to sketch this after you develop your asymptotes. After you find your asymptotes. Let's try one. Let's do the tangent of 2x. Maybe, oops, sorry. Okay, let's do the tangent of 2x. What does 2 mean I'm going to do? What does that 2 tell me? I'm going to shrink. I'm going to compress it. I'm going to have more asymptotes than less, aren't I? So what do you think? Where do you think my asymptote should be? If my asymptotes were at every pi over 2 where it's odd, where should they be? If I'm going to take half of that distance. If my asymptotes are at the odd pi over 2's, I'm going to take half of that distance now.
Maybe at 45.
At the 45's, I'm going to be the n pi over 4's when it's odd. I still have to keep the odd thing. So I start like this. I start with my regular domain for my tangent curve. Real, except, and I gave you a sheet that has all of them laid out. Remember the Xerox sheet I gave you? It's got all the domains and the ranges laid out for each one. And I said, even though we developed them, keep that sheet handy because in a case like this, have that next to you. So you pull this out and you say n pi over 2 where n is odd integer. Now, watch. Take this 2x. Keep this information. Solve for x. Cross multiply this. Make your life easier. And divide by 4. Ah! Isn't that just what Allie told me this was going to be? Where n is odd. So I stick an odd number in there. It's at 1. It's at 3. It's at 5. And I start like that. And I just make my asymptotes first. So here's my 90, my regular. Here's my 45. This is 1 pi over 4. Oh, got one. This is 2 pi over 4. Nope. This is 3 pi over 4. Got one. 4 pi over 4. Nope. 5. Got one. Now just make your tangent curve go in between. See it? Didn't we double up on those? A shrink and a stretch work a little bit differently in your functions. All right. Go through this homework packet. Save that sheet that I gave you. We'll go over that. But my advice